Hello, my fellow mathematician. Welcome to Study of Numerical Analysis. Today's focus is on how to derive the general formula for calculating errors of a function. We are going to consider several independent variables, and we are labeling them here as x1, x2, x3, all the way to xn, whereby n is the number of the variables, and these independent variables are subjected to the errors as follows: change in x1, change in x2, change in x3, all the way to change in xn. Then we are going to consider this function of x plus more change in x being given by function of x1 plus the small error in x1, comma, x2 plus the small error in x2, all the way to x1 plus the change in the small error in xn. Here, our f represent x1, x2, x3, all the way to x1. And here we are assuming that the errors in x1, change in x1, change in x2, change in x3, all the way to small change in xn are caused by an error in the function, in the change in function f. So we can express the function f in terms of the error in f this way: f of x1 plus change in x1, x2 plus change in x2, all the way to xn plus small change in xn. Now, from there, we can make use of Taylor's expansion, whereby we are going to neglect the squares of change in x3. And when we do that, we realize that function of f plus the error in f could be given by f of x1, x3, x2, x3, all the way to xn, plus small change in x1, partial derivative of f with respect to x1, plus small change in x2, partial derivative of f, plus all the way to small change in xn, partial derivative of f with respect to xn. We call this equation 3. So we can subtract 1 from 3. Our equation 1, it is the one here. It is the one here. F is equal to f of x1, x2, x3, all the way to xn. So subtracting f equation 1 here, this part here is going to cancel out, and we shall be left with the change in f, that is the error in f, is equal to change in x1, partial derivative of f with respect to x1, plus change in x2, partial derivative of f with respect to x2, all the way to small change in xn, partial derivative of xn. And now, this is the general formula for calculating errors of a function. So whenever you are given a function and you want to determine the error in that function, you can apply this formula here, and it is going to give you the required result in simple method step. So how do we now determine the relative error of a function? The relative error of a function can be obtained by dividing the error in the function with the actual function. whereby now when we redistribute the function in this equation, the result will be the required relative error as indicated here. So modulus of error in f divided by function f is the same as small change in x1 partial derivative of f with respect to x1 divided by the function plus small change in x1 partial derivative of f with respect to x2 divided by f, all the way to the last part, which is small change in xn multiplied by partial derivative of x with respect of xn to divide by the function f. Also, the absolute error could be given by relative error multiplied by the function f, and you are going to obtain your result. So thanks so much for taking your time to study with me today on numerical analysis. In particular, we have considered the general formula for obtaining the error that is in a function, and we have found the general formula is the one here. What we have done in this video tutorial, we have shown you on how to derive it. For more such learning, remember to subscribe to this channel so that you will be notified whenever I share the content concerning numerical analysis and the other field of applied demands. You can also leave the comment below on how this presentation could be made better for you, so that we may know how to make it better for us. Bye bye. See you in the next presentation, and thanks for your time.